This is 5.7, lesson 1. So for this lesson, we are going to solve systems of equations. That are not in slope-intercept form using substitution. So far, we've solved systems of equations that look like the ones below. So for letter A, we have a y equals by itself, so we get to substitute that second part of the equation in for our y in our first equation. Part B, we have an x by itself, so we get to plug this part of the equation in for x in our first equation. And letter C, we have a y equals by itself, so we get to plug in that part of the equation for our y in our second equation. So it says summarize the steps for the substitution method that you have used so far. Okay, so step number 1, we substitute one equation into the other. Step number 2 was solve for one variable. Step number 3 is plug that answer into an original equation. And then step number 4 is solve for the second variable. And remember, to solve for a variable, we will use these properties, which basically just means we add, subtract, multiply our numbers to both, or divide numbers to both sides to solve for our variable. So let's review. So part A, I ask you to isolate y, which means I want you to get y equals. The first thing we would need to do is subtract 8x from both sides. So we get 4y equals negative 8x plus 28. And then we would divide everything by 4. So we get y equals negative 2x plus 7. Part B says isolate m, which means I want m by itself. So in order to get m by itself, I'm going to subtract 16n from both sides. So I get negative 16n plus 8 equals 8m. We will divide everything by 8. So we get negative 2n plus 1 equals m. So it doesn't matter what our variables are, we can always isolate or get one of those variables by itself. So let's apply this to substitution. When we look at this system right here, in order to do substitution, one of my equations has to have a variable by itself. One equation has to say y equals or x equals. Well, I'm choosing to isolate the y in the first equation, which is this y right here. I'm choosing to isolate that one so that I can get it to say y equals negative 2x plus 13. Why did I choose this y? And why do you think I chose the first equation? So I chose this because there would only be one step to get this y by itself. If I chose any other variable in these equations, I would have had 2 steps to get the variable by itself. But since I do not have a coefficient or a number in front of y, I only have 1 step to get y by itself. So when graphing systems of equations, you must first isolate the y variable and put it in slope-intercept form. Okay, so I give you this equation here. So if I were to ask you to graph these, both of them would need to say y equals. Okay, so the first one is ready. I would start at -2, and I would go down 1 over 1. But my second equation is not ready to graph. So we need to get y by itself. In order to get y by itself, I will add 2x to both sides. So I get 4y equals 2x minus 20. And then divide everything by 4 to get y equals 1/2 x minus 5. So that means I start at -5. And I go up 1, right 2, so I already found my intersection. And my solution is 2, -4. I know it says to check, but we're going to skip that for now. Just remember to check your solution. You have to plug your ordered pair into both equations and make sure it works for both. Our second one, neither equation is ready. So we have y plus x equals 3. We will subtract x from both sides to get y equals -x plus 3. So it means we'll start at 3. We go down 1, right 1. And then my second equation, I need to again get y by itself. In order to do that, I would subtract 3x from both sides so that I get -3x minus 1 equals y. So I start at -1, I go down 3 and right 1, or I go up 3, left 1. There's my intersection. And our answer is going to be -2, 5. Okay, so now that we've done some practicing with getting y by itself, let's do this with substitution. So only one of the equations needs to be solved for an isolated variable. It could be x or y to use substitution. So looking at letter E here, we want to have one of our equations either say y equals or x equals. Well, the first one is going to be the easiest one to get a variable by itself. And we can get y by itself very easily because it does not have a coefficient. So that's our first step. We have 4x plus y equals 3. To get y by itself, we're going to subtract 4x from both sides. So we get y equals -4x plus 3. So that's what our first equation now is. Y equals -4x plus 3. Now that we have a y by itself, we can go ahead and do what we've done before. We can take this part of our equation and plug it in for y in the other equation. So we're going to have 2x plus 3 times -4x plus 3 equals 29. And then we can solve. So we have 2x minus 12x plus 9 equals 29. We'll combine our like terms to get -10x plus 9 equals 29. Subtract 9 from both sides to get -10x equals 20. Divide both sides by -10 to get x equals -2. Now remember, we can't stop here. Our answer is an ordered pair, so we need to figure out what y is. Well, in order to figure out what y is, we need to plug this x into one of our original equations, not one that you changed, into one of our originals. So we're going to do 4 times our x, which is -2, plus y equals 3. 4 times -2 is -8. We'll add 8 to both sides to get y equals 12. Again, it doesn't matter which one you plug it in. Oh, I'm sorry, that's 11. It doesn't matter which one you plug that into. you'll get 11 as your y. So our final answer is -2, 11. Then letter F, again, we want to do the same thing. We want to isolate a variable, but this time, the variable that's going to be easiest to get by itself is this x. Now again, you can pick any variable you want. It will work. I'm just trying to save you some steps here. So we have x plus 2y equals 20.5. And to get that x by itself, I would subtract 2y on both sides to get x equals -2y plus 20.5. So that's going to replace this equation. Since I have an x by itself, I am going to replace the x in my first equation with the second part of my second equation. So we're going to write this as 0.5y minus 3 times -2y plus 20.5 equals 3.5. We'll distribute to get 0.5y plus 6y minus 61.5 equals 3.5. We'll go ahead and combine our like terms to get 6.5y minus 61.5 equals 3.5. You add 61.5 to both sides to get 6.5y equals 65. Divide both sides by 6.5 to get y equals 10. Okay, so now we have y by itself, and so we need to figure out x. So we can plug it into one of our original problems or this one that we changed. So we're going to have x equals -2 times 10 plus 20.5. And that's going to give me an x equals -20 plus 20.5. So that means x is 0.5. And our final ordered pair is 0.5, 10.